It's time for another build, only this time we're going to be utilizing Intel's latest generation CPU, the Kaby Lake based Core i7 7700K. Here are the parts that are going to make up this build, starting with the case. This is the Corsair Carbide Series 200R. You've seen me utilize this case a lot, and that's because I don't think there's a better case available for the money. Over here on my left, your right, you'll see the Corsair RM550X modular power supply. And then switching over to the other side, this is the stuff you really want to know, right? I know you can see this Hyper 212 cooler. Let me move that out of the way. This is an ASUS TUF Z270 Mark II motherboard. We've got 32 gigs of Corsair Vengeance RAM right here, the LPX series. The, as mentioned previously, Core i7 7700K CPU. This is fresh off the factory floor, 4.2 gigahertz. And we're going to pair that into a Samsung 960 EVO M.2 drive. And this size is 500 gigabytes. Of course, next to that, we have our optical drive. Yes, some customers still want optical drives. You know, they're only $20. It's not like you save a lot of money by not getting it. And for our operating system, Windows 10 Home 64-bit. I don't know why anybody would run a 32-bit operating system anymore unless they have specialty needs. But for most of the people watching this video, whether you're choosing Windows 7, Windows 8, or Windows 10, you definitely want to go with the 64-bit, or you'll be limited to just 4 gigs of memory. Regardless of what you build, the first step is always going to be prepping the case. So with prepping the case, we need the power supply, we need any drives we're going to install, in this case just the optical drive, and we need the motherboard I/O shield, which comes with your motherboard in the motherboard box. It's pretty easy so far, right? We're just going to put in 3 components. So we start, of course, with the case. Case comes with instructions. The instructions on most cases are fairly useless, so just set them aside for later reference. I'm going to start by taking the panels off of the case. Now, if you have a different case, yours may open up a little differently, but on this one, we're just going to remove the 4 screws that hold each panel. Each panel is held on by 2, so we're going to remove a total of 4 screws to remove the 2 panels. So with this case, as I've shown in other videos, this panel just slides back about 1 inch, and then it just comes right off. And then we're going to set that down. Set it somewhere where you aren't going to damage it or accidentally knock it over or trip over it, because it's almost impossible to just buy a side panel. You'd almost have to buy a whole nother case just to get the side panel. So be aware of that. And these are going to be the last things we put on. Once the computer's completely built, the side panels are the last thing. So put the screws away. We're not going to need them for a little while. Now with the case opened up, if I turn it around here, you'll see every case comes with a little packet of hardware, little bits of screws and things of that nature that accommodate the case. And every case is different and has different requirements for the screw types. So all the screws you need to mount all of your hardware will come with your case. With the Corsair 200R, you'll see there's a cardboard box right under here, if you can see my hand. And I'm just going to pull the lever that would normally hold our hard disk drive in place and then slide the box out. Now inside of this box, not only do we have the screws, but Corsair also includes some nylon zip ties for cable management. And the rest of that box is empty and can go in the recycle bin right over there. The very first step I like to do, because it's just so easy, is to install the optical drive. And installing the optical drive, we just have to push out one of these front plates. It doesn't matter which one, they all work the same. I like the aesthetics of having the optical drive on top. So I'm going to just grab the optical drive here and just slide it in from the front. It does not go in to the computer and then pushed out. It goes in from the front, and then you will slide that in and it will just lock right into position. There's a little metal lever on the Corsair 200R, and again, every case is different. So if you don't have this exact case, you'll have to either read the manual that came with your case or look at a YouTube review of your case or just figure it out. It's not rocket science. And anyway, if you just pull this lever out, then push the drive, and you'll see the drive just slides right out there. So I just want to pull that back in. I'm going to make sure that that's pushed back in too. There's really no spring mechanism on this. It's just a piece of metal, so sometimes it needs a little assistance after you've pulled it out. So with that done, we can install our I/O shield. The I/O shield's incredibly simple, and this is one of those things I see people struggle with a lot. It does take a little bit of practice, but all you're doing is putting this in with friction fit. There's no screws involved. It's the exact size it needs to be to fit into the cutout on the case. But I will say, if you're using a very inexpensive case, not only can you easily cut yourself, but this can be a real hassle. It seems like on the less expensive cases, they don't really cut it to such precision as the name brand case manufacturers. In fact, I shouldn't even say that, because Antec has a series of cases that are some of the worst I've ever seen, and I think it's a shame that Antec has diluted their name. I think if I was Antec, and here's a little free advice for you, Antec, if you want to make junk cases, don't use the Antec name on them. You know, come up with some other name and make that your budget line, because it's hard to recommend to a consumer a brand of case if that brand makes both good and bad cases. So for example, I don't think there's really a bad case Corsair makes. I'm not a fan of the Bulldog. I don't know if you've seen that case. I'm not a fan of it, but I wouldn't say it's a bad case. I just don't like the layout. There's really a difference between opinion of the layout of the case versus the quality of its construction. So what I'm saying is the big name manufacturers like Corsair, NZXT, Fantex, Bitphoenix, I'm sure I'm forgetting quite a few. Those are big name case manufacturers that manufacture quality cases. Thermaltake's another one. Case Labs is another one. If you spend the money and pay for a case from any of those manufacturers, you will get a good, solid construction case. So back to putting the I/O shield in, you'll see this I/O shield has small holes on the bottom. That's for the audio, and that is the bottom. Now again, depending on the case layout, sometimes it goes in the other way. But most mid-tower ATX cases, the majority of them, will go in this orientation. And it's not a big deal if you were to put it in upside down and you went to install your motherboard, it won't fit. You just pop this out and turn it around. So you don't have to fear doing it wrong. The instructions for this are incredibly simple. You take the rectangular peg and you place it into the rectangular hole. I mean, that's pretty much the instructions. Not real complicated. It is going to be a tight fit, so you should work on the bottom first. Make sure the bottom is in. Push on both corners, then come up to the top and do the same thing. Get both corners in. You should hear it click, and you should also see a little ridge coming out along the sides equally. If any part of the ridge doesn't have the same depth as the rest of it, then obviously it's not seated completely. So just make sure you hit those four corners. You typically will hear it click into position. Then finally, we can install our power supply. So again, here we've got the Corsair RM550X. And they do like their packaging, I will tell you that, because we have a box, and inside of that box, as you'll soon see, and I have to say, this is actually more difficult than installing the power supply. Inside of this box, there's another box. And then inside of this box, well, we've got some tape here, which is a pain. So I'll just cut that tape. There we go. We've got one heck of an owner's manual, but don't let this intimidate you, because the only part of this that's written in English is, let's see, English. That's it, right there. And this is all other languages. So enjoy that. Warranty guide. Hopefully, you'll never need this. And if you do, you just go to Corsair's website and all the information's there anyway. Power cable. We'll need that at the end, so that'll get put away. We've got more nylon zip ties, a little case badge is in here. Makes your PC go faster if you put it on, I guess. We'll set that aside. In this bag are all of our modular cables, which we'll get to later on in the build. So for now, just set that aside. We've got a bag of silica gel, which says it's silica gel, do not eat, throw away, desiccant. And if you're familiar with my videos, and you're familiar with my personality, when I'm told not to do something, it makes me want to do it. So now, it's kind of rude to talk with my mouth full. Needs salt. Anyway, what's left in the box is egg crate packaging, which that can go in the recycle bin. The crushed velvet bag, which really is, I would rather, honestly, I would rather that Corsair remove this velvet bag and take the price of the velvet bag off of the cost of the power supply. This bag is completely worthless. Now, some people in the comment section of earlier videos have said, no man, you put your cables in there, man. And it's like, no, that's what this bag is for. Unless the box in a box means you put your bag in a bag. Because if you did that, you know what's in here? Another freaking bag. Are you kidding me? How much of my power supply cost was bags? So, all right, calm down, take it easy. Deep breath. Okay, back of the power supply, you'll see we've got these connectors here, which we're going to refer to a bit later. And you'll notice that there's a fan here on the bottom. This fan sucks air in, it doesn't blow air out. So you can put the power supply in case with the fan up or the fan down. The case is designed with the fan to be in the down position, and the cables on a lot of power supplies actually come out of the side closest to the edge of the case to make for cleaner cable management. Because this is modular, it actually doesn't matter if you mount it upside down or right side up. There really is no upside down. And unlike Seasonic in an earlier build, I was complaining because some of the writing on the back was upside down. No matter how you... People say, well, that's so you can turn it around. Well, that's what Corsair's done here, only they did it the right way. You'll see here the writing is right side up. But on this side, it's upside down. And that's because you'd have to flip it over to install it with the fan up, and then the writing would be right side up. So this is the proper way to do your writing. Seasonic has the writing upside down no matter how you place the power supply. Some of the writing is upside down. Now there is a small little warning here, right here on the back. It says, silent operation at low to moderate loads. In this mode, the fan will not spin. In other words, if this fan is not spinning, they don't want you calling them for an RMA. That's normal. It's to reduce noise and reduce dust. And this fan doesn't actually bring any air into your case at all. It brings the air in from outside, and it just comes right out here. So it's strictly dedicated for cooling the power supply only. Now again, I want the fan mounted down. If this was going to go somewhere that had carpeting, I would recommend mounting it with the fan up. Either way, it's going to work just fine. So this is going to go into the case. Let me just turn the case around so you can see there's a metal tab right here. And I want to put the power supply in, again with the fan down, with this end of the power supply facing out. And I want to just set it in here and push it to the back of the case so that it lines up, and then slide it back. Use the screws that come with the power supply. However, if there's a color difference and you want your case to match colors, then definitely use the screws that come with the case. In this instance, everything's black anyway, so it's 6 of one, half dozen of the other. I want to go ahead and use these screws. So I'm just going to get all the screws started. You want to keep the screws loose so that you can move the power supply around as necessary to line up the mounting holes. And you'll notice I didn't use the top mounting hole up here either. Pay close attention to the holes I'm using, because you'll want to replicate that and it'll prevent you from struggling. And this screwdriver that I'm using, again, I've got to acknowledge some of you have never seen my videos before. This is a Panasonic EY7410. Me and this screwdriver, we're pretty close. This is a pretty expensive screwdriver, and you don't need to have one of these. unless you're going to be building a lot of computers. But I will tell you this, if you've never built a computer before, you're going to want to build a lot of them. You don't believe me? Prove me wrong. All right, that gets our power supply installed, our I/O shield, and our optical drive. Now it's time to prep the motherboard. All right, now we get to prep our motherboard, which is going to utilize all the rest of the parts we have aside from our Windows installation disk. Now, if you have an electrostatic discharge anti-static strap, you should put that on now. If you don't have one, no worries. Just handle the parts the way you see me handle the parts, and then touch your case from time to time. The case not plugged into the wall, just touch it. You'll be on the same electrical level by doing that, and that's what's going to dissipate any electrostatic discharge from your body. It only takes about 9 volts to damage a component, but it takes 9,000 volts for you to feel the static discharge. So at the very least, just handle the parts the same way you see me handle them. And if you can work on any other surface other than carpeting, that would be preferred. Tile, wood, laminate flooring, any of that's preferred because that's less likely to develop any static in your body. So we're going to start by removing the motherboard from the box here. And as you see, they've got the motherboard in an anti-static bag. We'll go ahead and take that out. We're just going to set that down. How you handle the motherboard while it's in the anti-static bag doesn't matter. You'll see we've got a little cardboard divider, which we'll get rid of. And then in the box, the motherboard box, we've got the instructions and driver disk. We've got SATA cables. We've got the Q connector. We've got a bridging connector, an SLI bridge if you're going to have 2 video cards. We've got a bag with nothing in it. Okay. There's this CPU installation tool, which is completely needless. And then our M.2 standoffs, which I covered in a previous video. And I have no idea what was in this other bag. It's just an empty bag. I don't see anything else in here. It's a 5-year warranty on this motherboard, a certificate of reliability. So it's good to know the certificate is reliable. Yeah, I don't know what else could have been in that bag. Oh, and we have a stencil. Well, it's not a stencil. It's a vinyl graphic that you can put on your case, and I guess that'll make your computer, you guessed it, go faster. It's like painting flames on the hood of a car. It adds like 100 horsepower. All right, so we don't need any of this stuff for right now except for those little standoff screws for the M.2 drive. And I don't know, again, I don't know what this empty anti-static bag was for. That kind of bothers me. So in the motherboard manual, if we really want to know what that was supposed to be, they should give us a list of contents in the bag. Here's the contents in the bag. So it looks like we've got everything. Again, I don't know what was in that anti-static bag, but clearly nothing's missing. So perhaps just a mistake in the manufacturing, in the warehouse where they assemble, put all the parts in the box. I can find the words. I'll get there. All right. And what's this? Something, here's a coupon for 20% off cable mod cables. Well, it's nice that they throw that in there if you're somebody who wants that. So at this point now, I'm going to take the motherboard out of the bag and we're going to work on the box. That way we don't scratch our countertop and we have less chance of any static discharge coming up from behind the motherboard. I'm going to touch the case, make sure I'm on the same electrical level. And I like that ASUS is no longer taping these bags closed. I never understood why they did that. It was really a hassle to get through the tape sometimes. And it's not like the motherboard's going to go anywhere once it's in the bag and in the box. It's not like it's going to break loose of the bag. So kudos to ASUS for not putting that useless piece of tape on the bag. Now I'm just going to grab the motherboard by the PCI slot and the edge, and I'm just going to slide it right out of the bag like so. This anti-static bag, we don't need that anymore. Then I'm going to take and hold the motherboard by the edges. You'll see on the bottom there's a lot of little pointy solder points, and they will break through your skin, and they're painful. So it's in your best interest to properly handle the board. Besides which, touching any of those silver points is a great way to dissipate static out of your body. And once again, even if you don't feel it, doesn't mean it didn't happen. So if you touch it by accident, everything's probably going to be okay, but there's nothing else you can do. Sometimes I get these comments from people. They say, I accidentally touched it. Will it work? There's only one way to know. Plug it in and find out. It's probably going to work fine. I just want you to avoid that scenario so you don't have that anxiety. Look on the motherboard for any heat sinks. There's often plastic covering them up to protect them in shipping. You want to remove any plastic coverings because when the heat sinks heat up, they can cause a smell of the plastic burning. It's not pleasant. So here on this heat sink, I'm not quite sure how well the camera's picking that up, but there is a piece of plastic right there. See that? We want to get rid of that. I think that's the only one. Grabbing the CPU box, you'll notice one side has a very large label on it. We want to leave that side alone. The other side will have a small piece of tape. So just open it from this side. It's a lot easier. And Intel has changed a little bit of the packaging on the CPUs now. I don't like this new packaging, but it is what it is. And we're going to open that up. We'll get rid of this box. These are instructions with a little go faster sticker. That can go over there. And there is our CPU right there. And we're just going to take that out of the cardboard and get rid of the cardboard. Now the CPU itself is not very fragile, but we still want to handle it properly to avoid any static discharge and to make sure we don't get any contamination on the surface of the CPU or the bottom of the CPU, which could interfere with the connections on the bottom or the heat transfer of the thermal compound later on. If you do end up touching the top of it, you can always wipe it clean with rubbing alcohol and a Q-tip and just let it air dry, and that'll be just fine. Notice there's a little corner cut out of the plastic right here, and that's to get your thumb under there and lift the lid up on the container. And there are two cutouts in the container on each side, so we can pick the CPU up and take it out, and we can get rid of the container. Notice how I'm holding the CPU? It's not very difficult to hold it this way. You don't want to hold it like a potato chip. That would be wrong. One side of the CPU has a little gold dot right down here in this corner, and it also has little grooves cut out in it. Also one by the gold dot right here, and then one exactly opposite here. And that's to ensure that this will only seat in the socket in the proper direction it's to go in. Now the socket, let me turn this around so you can see, is this part right here. And we're going to push this lever down in a way, and it's going to lift this lid up, and we might need to help the lid up a little bit. There we go. Now, as I mentioned, there is a CPU installation tool, which I think is more difficult to use. Basically, it's a little plastic frame that you put the CPU in, and you seat it down, and you leave the little plastic frame on it, and you're done. I've always done it this way without any special tools. It's always worked for me, and I've been in business for 25 years. Never had an issue. I believe if you follow the way I do it, you don't need that CPU installation tool, but use your discretion. The writing on the CPU, if you can see the writing on it, you can read it, right? If I turn it, then suddenly you can't read it anymore. It's sideways or upside down. And the writing on the motherboard also faces that same direction. There's a lot of different ways you can tell which direction the CPU goes in. One of those ways is simply following the writing on the board, unless it's a mini ITX board. With regular ATX or micro ATX boards, it always follows the direction of the writing. You can also look for the little notches in the socket and the little dot, which is usually indicated. Here we've got it. It's moved since I showed it to you. I was wrong before. It's not the gold dot, it's the gold arrow down here. And there's usually an indication on the board that matches that. However, this board doesn't have one, I guess because they figure you're going to use the installation tool. But it's easy enough to tell where the little notches are. And again, as long as you keep the writing and the right side up, you really can't seat the CPU incorrectly. It simply won't fit flush any other way than the way it's intended to go. And the way I set it in is I will just seat a corner. Like I'll just put the two corners in like this. Hoping you can see that. And then I gently let the CPU sit down and rest gently into its socket. You can grab the edge and just see if you can twist it. It shouldn't twist. And that makes sure that it's in the socket. Now, the pins underneath that CPU, they're very, very delicate, and that's why this little plastic cover is here. If you have a warranty issue with your motherboard, you are going to need to send the motherboard back in, let's say for an RMA. You'll take the CPU out. You're not going to ship your motherboard back with your CPU. Anytime you remove the CPU, you need to protect those pins with this little plastic cover up here. So keep this little plastic cover, because if you ship the motherboard back without it, your warranty will be void, and that's with all motherboard manufacturers. Now, hopefully you're never going to need this cover again, but I suggest you take all your instruction manuals, all your spare parts, all the spare screws we didn't use, all the spare power supply cables we're not going to use, put them all together in the empty motherboard box when you're done, and that way if you need to upgrade or repair or change something in the future, you're going to have everything in one place. Now, with the lid closed, the final step is to simply lower this lever back down. It's going to have some tension on it now, and that little plastic cover that I've been talking about should pop up on its own, and it did, and we'll just put that away. Here we've got our 32 gigs of RAM. This is 4 sticks of 8, and we're going to use all 4 sockets, obviously. Its speed is 2133. Obviously, if you're planning to overclock, you're going to want to get faster RAM than this, but this is really good RAM. I highly recommend it. It's very reliable, and it's very fast. So we're just going to go ahead and take the RAM out of the box, and we're going to have 2 packages of 2. Now, if you're only installing 2 RAM modules, refer to your motherboard to determine which of the 2 sockets you're supposed to use. Here's a hint. It's probably not the ones you're going to assume, so that's why I'm recommending you use the motherboard manual. And just because you put it in whatever socket you want and your system turns on does not mean you did it right, and it does not mean your system is operating at its peak performance. I'm just going to go ahead and set one of these aside. And the one thing I don't like about the Corsair Vengeance RAM is they have these little plastic covers over their logo, and I find that to be completely pointless. They put the cover over where it says Vengeance. It's not like that's going to get scratched. And again, it could heat up and it could start to have an odor to it. So I'm just going to go ahead and open this up, and I want to peel that plastic off of here. This is also a good time to go ahead and touch your computer case just to make sure you're on the same electrical level. And there's that little label, that little plastic cover I was talking about. Now, it doesn't matter which of these sockets we start with. If I start with the one closest to the camera, you won't be able to see me install the others. It really bothers me when I see other people's build videos and they do that. So for the sake of the camera, I'm going to start with the socket closest to me, and I have to turn the memory module so that the key or the notch in it lines up with the notch in the socket. Again, making sure all of the retention levers are open. And we're going to gently set that in its track. You definitely don't want to use any brute force here. Memory is very static sensitive, it's very fragile, and it's important you handle it the way you see me handling it. This memory has a little heat spreader on it, so you can hold it anywhere along the heat spreader. Where it makes connection to the board, you don't want to have your fingers touching that. So I'm going to go ahead and just push down on one corner and then the other corner. And we're going to repeat this with the remaining 3 modules. Now, installing our M.2 drive is going to be really simple, and we have 2 places that we can place the M.2 drive. As you can see, we've got a spot here, and we've got a spot here. Now this spot, you'll see there's only 3 positions, and this one has 4 possible positions. That's because M.2 drives come in different lengths. The most common is the 2280, which is what we have, and it looks like a stick of gum. That's why I call the M.2 drive a gum drive, because it looks just like a stick of gum. And as I mentioned, it's only going to use this 3rd position here, so it doesn't matter which one of these that we use. Generally speaking, this part of the motherboard is the hottest, and the hotter these drives get, the slower they go. So I want to keep this as far from the heat as possible. That's why I like, some motherboards have the M.2 sockets behind the motherboard, which is a brilliant idea. ASUS typically, if you only get one M.2, it's usually down here to keep it away from the heat. So for that reason, I'm going to use this one This is one we're not going to use, but the customer can always use it in the future. And yes, it's possible to put two M.2s in a RAID configuration and have it even be super fast. I mean, this thing reads, I think, up to 2,500 megabytes per second, some crazy number. So imagine RAID 0 in a stripe formation and probably get close to 4,000, 5,000 megabytes per second on your sequential read speeds, which is insane. But this customer actually is going to be blown away by just the base speed of the whole system by itself. So no sense in doing that. Now there were little standoffs that came with the board for the M.2 drive. For the Samsung M.2 drives, these little standoffs are not required. However, without them, the solid state drive will sit on an angle, and with them, it'll sit straight up. It's just an aesthetics thing, but ASUS includes these because there are some manufacturers of M.2 drives that might ground out against these other mounting points. So they recommend using these, if for no other reason than it just looks better. So I'm going to go ahead and take the M.2 drive out of its box here. And this is one of the best ones you can buy today, the 960 EVO. Now Intel does have a new type of solid state memory in development called Optane, and this motherboard does support that. It's just not available yet, but hopefully we'll see it come out sometime in 2017. It was supposed to come out in 2016 and never did. Now I like how Samsung has now packaged this. If you recall in other videos they had plastic within plastic within plastic. There's no anti-static bag. This container is an anti-static material, and you'll see, just like I described, it's like the shape and size of a stick of chewing gum. We're just going to take that right out of there. You notice the little indentations? That's what they're there for, to get your fingers in there and just lift it straight out and get rid of that. Now again, notice how I'm holding it. All the parts I always hold by the edges, but because there's nothing on the bottom but a sticker, and there's nothing on the top but a sticker, well, there's things underneath the sticker, you can hold it by the stickers. So what I'm going to do is I'm going to line this up with the slot here, and it just gets, I'm going to push it, and you heard it click, and all the little gold fingers here on the end are now not visible. And when I push this down, you see it looks kind of like a diving board. When I push it down, you'll see it lines right up with that hole I mentioned earlier, which would be this one up here. So yes, they do make these things this long. So you'll see that if I mount that with the mounting point right now with the screw, it just kind of sits on an angle. So I'm going to go ahead and take this back out and set it down here. And we're going to grab the little standoff and screw that in. And this does not have to be super tight. As long as you get it flush, that's good enough. We're not making anything watertight here. Now, if you want to tighten that down even more, although it's not recommended, you should know that it's the same size socket, the 5mm socket, that standard case motherboard standoffs use. So at least that's all universal. And don't tighten it too much. I can't overstress that. You do not want to crush the motherboard by tightening it too much. Now if you look closely at the M.2 drive, it looks like it's missing a tooth. It's got that little slot carved out in it. And that's to ensure that we can't put it in upside down. It will not go in this way. It will only go in with the notch matching the socket. And you line it up on an angle, just like you see me doing, and then push it with a little bit of a wiggle, and it'll seat right into that socket, and it'll pretty much just hold itself there. So then finally you're going to grab one of the little tiny screws that comes with the little bag of standoffs, and we're going to need a number 1 Phillips screwdriver, something that's got a finer tip on it, because the standard computer screws are number 2 Phillips. And it's important that you use a magnetized screwdriver so that you don't drop the screw and potentially lose it or get it jammed underneath a heatsink or scratch the motherboard. So magnetic screwdrivers are very important to use when building a computer. And so I'm just going to use one finger to gently hold that down, and we're going to just put that screw in. And you definitely do not want to over tighten this screw. All it's doing is holding this M.2 drive in place. It's just securing it in position and nothing more. Now, one other thing I want to mention is that there are Among different sizes of M.2 drives, there are also different protocols for how the M.2 drive talks to the motherboard. So this is called an NVMe, or non-volatile memory express. I just call it NVMe because it is much, much faster than a standard M.2 or solid-state drive. The regular M.2 drives and regular 2.5-inch solid-state drives that you see me install, those still run at the same maximum 550 megabytes per second. If you want to break that speed limit, you've got to go to an NVMe-based M.2 drive or drive that will plug into one of the PCI-Express slots. Now, the regular M.2 drive has 2 keys in it, or 2 notches, and an NVMe drive only has 1 notch, as you see in this diagram. And if your M.2 drive is not fitting, do not force it. It's very important when you buy an M.2 drive that you make sure, specifically if it's an NVMe drive, that your motherboard supports NVMe. Because the regular M.2 drive will fit in an NVMe socket and run at the slower speed, but not the other way around. Now, it's really up to you at this point if you want to put your cooler on. If it was a stock Intel cooler, it's simple enough to put on now. However, the Hyper 212 Evo that we've got here, I find is a lot easier to install once the motherboard's been secured in the case. So let's do that now. Now, I've actually put the computer on the floor in order to give you the best camera angle. I'm not recommending you do it this way, but this is strictly so you can see better as to what I'm about to do. These little things that stand up off of the back of the case are called motherboard standoffs, and they're to keep the back of the motherboard from touching the metal, which can ground out and cause all kinds of problems. And the biggest mistake people make when they build their own computer is they don't ensure that these are all in the right place. And if you put your motherboard down and there's a standoff where there is no mounting hole, you'll never see it, and it'll make contact with metal on the back of the board and short your motherboard out, and that's not a warranty issue. So this is a pretty standard layout. And one of the things I like about the 200R is that the standard standoffs in the standard positions are pre-installed, and you should not have to change them unless you're using a micro ATX motherboard. But on a regular ATX motherboard, which is what we have here, you shouldn't need to move any of these. But just to make sure, it's very simple to count how many holes you have on your motherboard. So this motherboard's got 2 holes on the bottom, 3 holes across the middle, yes, and then 2 holes on the top. So that's a total of 2, 3, that's 5, and 2 more is 7. So here on the case, we've got 3 across the bottom, 3 across the middle, and 3 across the top. And this one right in the middle of all of them actually doesn't take a screw. It actually it sticks up a bit. It's got a ridge on it, and that's to hold the motherboard into position. And again, not every case has that, and it's very useful in assisting with the installation of the motherboard. So here I've already got the motherboard turned in the proper direction. This is our I/O ports here, and our I/O shield is here on this side. I'm going to just grab the motherboard by its edges, and we're going to set this down in here. Now, you'll see this fan cable's kind of in our way, so we want to get the fan cable obviously out of the way, or that'll interfere and make our job much harder than it needs to be. So just get that out of the way. And then this isn't just going to go straight in. What you have to do is you have to tilt the front of it down, and you want to line up the holes on the I/O shield with the I/O ports themselves. And as much as possible, you want to hold the motherboard by the edges. And when motherboard manufacturers put this shroud over the I/O ports, it makes it very difficult to see what you're doing. So what I'm going to do is I'm going to line up the holes as best I can here with the speaker holes. So there's a slight angle, and then I'm going to push it forward. And I just heard it click. And right here, the center post should go right through that mounting hole, which it did. And now we can check this side of the board and make sure all of our ports are lined up as they should be. Now, if you look closely, this standoff right here does not line up with anything. You'll see that the standoffs here on the edge are for a bigger motherboard, and we're not using those. And if it just touches the edge of the motherboard, that's fine. These actually don't come out, so you can't remove them, and nor should you. But there is a hole right here, and it's a shame to see that ASUS is doing this, because initially it was Gigabyte that was being non-standard, and now it looks like ASUS has joined the club with a non-standard post right here, or a mounting hole. And you can go ahead and leave it empty. You don't need it to put anything in there. And don't worry about that. We're not worried about so much having an unused mounting hole, so much as we're worried about having a standoff back behind the board somewhere that we can't see it that would cause a short. It is disappointing to me when manufacturers do this. There are little plastic standoffs you can buy to put in there to keep the board from starting to droop over time, but that's less likely to happen these days than it was, back in the 90s. That was kind of a problem. So again, we can go ahead and leave that one blank. So basically, we're going to need 2, 3, 4, 5 screws. That's all we're going to need. So in the bag of screws, or one of the bags of screws that comes with the motherboard, there's one bag that has these short, coarse-threaded screws. Here's a close-up of what they look like. And we need 5 of those. Now, I'm going to recommend that you turn these by hand. This electronic screwdriver has a clutch on it that ensures the screws will not be over-tightened. But if you're not familiar with how your electric screwdriver feels when the screw isn't threaded properly, it's very easy to cross-thread, and you definitely want to use a manual screwdriver, unless, as I mentioned, you're very familiar with how your cordless screwdriver feels if a screw is getting cross-threaded. Now, there's no particular order that you have to put these screws in. At this point, I just want to get them all started. And once again, the reason you don't tighten them down yet is so you can wiggle the board as necessary to get any of the mounting holes lined up as need be. See, I thought that one went in and it didn't. Let me do that again. So this is a prime example of what I'm talking about, where the board needs to come forward a little bit. So I'm going to push in on the board with my left hand. It's your right, my left. And then we've got the last screw right here. And we can go ahead and torque this one all the way down. And then let's make sure all the others are torqued down the same. And you do hear the screwdriver shuts off when it hits a certain torque setting. Nothing else there. And that's the motherboard mounted in the case. What I'm going to do here, first of all, is to get all the parts ready for the Hyper 212 Evo. There's the cooler itself right here. It's got a piece of protective tape here on the bottom, and that's just to keep this area clean for when we apply our thermal compound later. Well, they've really done a much nicer job of packaging this since the last time I've installed one. That's really neat. That is much better than the plastic bags full of parts. Very cool. Good job, Cooler Master. I like that. It's a vast improvement over what you guys had. So the trick to this really is that I've got to have one hand back here lining up this plate here on the side and holding it while I install little standoffs to hold it into position, which is in this little plastic thing here full of parts. Now this bracket is very important. This bracket is the piece that goes on the back of the motherboard. And you'll notice it's got little bits of green here on the corners and fully on the back here. And the reason it has that is that on AMD systems, you would put this flat green part here, which is a non-conductive material, right up against your motherboard. If that wasn't there, it would completely short out your motherboard. It would completely short circuit it. So that's why that's there. On an Intel system, this actually is bent a bit away, and the part that does touch the motherboard, these corners, have that non-conductive material on there so nothing will short circuit. And if you look very closely, you'll see there's a long slot with little notches in it, and that's for the different screw positions. There are actually 3 positions the screw can go in depending on which socket you have, and that'll be real easy to figure out once you try and put the screws in. And you'll also notice there are 3 holes, 2 here on the top, 1 on the bottom. And if we look on the back of the socket here on the motherboard, you'll see there are 3 screws coming through. So that's how you know which direction to put this on. So here's where things get a little tricky. And as you can tell, we can see the screws through the holes. They don't actually come through. So what I have to do is I have to grab one of these standoffs. And like I said, this is a difficult thing to film, but I need to hold on to that with one hand and put the standoff through the mounting hole here. Any of them, doesn't matter which one you start with. And let's see if I'm coming through the other side. Yes, I am right there. And I'm going to grab another one, and you know, this is where it gets tricky because I can't really secure that in place yet. So I'm going to grab another one and just go to the opposite corner. So I'm going to come right down here. Let's make sure that that's lined up. And sometimes you have to rotate them in, and that's okay, or wiggle them a little bit. Let me come back around and see what's happening on the other side. Yeah, we're through. Okay, so with that, I can let it go and it's staying in position, but if I knock it or bump it, it's just going to fall up and, you know, come off, and I'll have to do it over again. So I'm going to grab one of these nuts here, and I'm going to go ahead and put that on loosely. I want to just get it started. See, it's already, you can see why this is so much fun. But this is there is an enjoyment in this. You know, if it was all too simple, there wouldn't be any fun in it. So this is a little bit of a challenge, but it's really not difficult. It just takes a little patience. Take your time, enjoy your build. Get that screw started, just like so. Try to avoid touching the back of the motherboard as much as possible. Try and keep your hands off of the silver parts. As I mentioned, they will easily cut you, and you can easily and accidentally release a static charge from your body. So it's also a good idea to, once again, touch the case from time to time, put yourself on that same electrical level. So I don't want these too tight because I still want to be able to wiggle this around in order to get these last two standoffs to fit. So hopefully I can film this a little bit better. We're just going to place that right inside, like so. I'm going to hold on to that with my finger, come back around, put the screw on here. You know, it's just a little tough getting the bolt or the nut here started, but once it starts getting threaded, it goes on very easily. Finally, we just have the last one, and you can see where those standoffs are here, right? In each corner, they're the only holes around the CPU, so it's not a mystery as to where these go. And I'll place that one in right in there. And you'll see it just doesn't slide in. I have to sort of wiggle it and push it. Then we'll come around, and if you notice, it is going right into that middle of that slot, which is exactly where a socket 1150 or 1151 will go. For example, the Hyper 212 Evo instructions don't even say socket 1151 as an option. They do say socket 1150, but there's no difference in a socket 1150 or 51. Sometimes the instructions will say a socket 115X, and the X being a variable, that it could be any number after that, and it's compatible. So we'll put the last one on here, the last nut. And once again, just getting them started is the hard part. Now that we've got them started, we can use the nut driver, which is this part here, and it's going to fit right over the nut, like so. And let me grab my mechanical screwdriver I've got right out here, and I'm just going to hold on to the other side while I turn this and tighten it down. And then I want to immediately go to the opposite corner. And this is important. You definitely want to do the bolts in opposite corners to make sure that it's not going to be warped in any way. And you want to make these pretty tight, but don't over tighten them. You can crush the motherboard. So I don't know if you can tell just how much force I'm using, but I'm pretty much turning it until it just won't turn anymore. Whoops. All right, so that is our Evo 212 mounting bracket. right there placed into position. You'll see the inside of the motherboard looks a little bit different now with the 4 standoffs sticking up. And now, this part can even be more challenging than that. And that is, we take this thing that kind of looks like scissors, and you'll notice it has these screws, again, once again, they're in a slot. And we want to move all these screws to make sure that they're in the middle to match the bracket. That's going to save us a bit of a headache trying to get these things to line up once we're in there. And I found if you just pull up on the screw, it easily moves wherever you want it to move. So I want all these screws in the middle, just like that. With the bracket in this position, just slide it in this way. And you want it to sort of close around these heat pipes. That's the proper way. And there is a very small hole in the base of the heatsink, and a little tiny post that sticks out that will go right inside that hole. And you can hold it into position. But what you don't want to do, once I remove this tape from down here, you do not want to touch this area. Like I said, that's where your thermal interface material is going to go, your thermal compound. And you don't want anything to contaminate that, whether it's oils from your skin or dust in the atmosphere. All that can affect your temperatures. Granted, it may not affect it that much, but if we want it to run as optimal and as efficiently as possible, it's important we follow these steps. Now I'm going to go ahead and apply some thermal compound, which we have here. And there's a lot of misinformation about thermal compound on the internet. And the bottom line is you just really need to use some thermal compound. It almost doesn't even matter what kind you use. As far as your temperatures go, it probably won't make a difference of more than 1 or 2 degrees centigrade from an expensive thermal compound to an inexpensive thermal compound. You only apply the thermal compound to the CPU. You do not apply it to the heatsink. Some heatsinks come with thermal compound material already applied, in which case you wouldn't apply any. You would just simply attach the heatsink. So I hope that doesn't confuse you. It's very simple. Now, the second bit of misinformation that's out on the internet is the proper way to apply the thermal compound. Some people say you put a pea-size, or not a pea-size, a rice size drop in the middle. Some people say you should put a drop in each corner with a drop in the middle. My concern about doing it in that way is I cannot ensure I have complete coverage over the entire surface of the heat shield on top of the CPU. And you got to remember, half of the CPU is a graphics card right in there. So some people say it doesn't matter, it's just the middle you want to keep cool. Well, that might have been true 10 or 15 years ago, but that doesn't apply today. You want the entire surface covered, and you want it covered evenly. I've even heard on the internet somebody saying you can't use too much of this stuff, but that's not true either. Using too much thermal compound can be worse than using none at all. So you run into this problem, right? If you just put the little drop on and then you lay your CPU on top, you don't know how much coverage you've got. If you put too much on, it oozes over the sides, and it's messy. It's very difficult to clean up. Now, you're welcome to put it on any way you want to. It probably won't make any difference in the world with regards to your cooling, how you choose to put your thermal compound on. But me, being in business for 25 years, I have always done it the same way, and I'm going to share with you what my way is. Here I've got just a roll of Scotch tape, ordinary everyday Scotch tape. I'm just going to take a piece of that off and put it here on my finger. I'm going to try not to touch the top of the Scotch tape. I want the non-sticky side to be as free from contaminants as possible. I'm going to just dab that thermal compound, and I want to spread it across the entire surface of the CPU. I want to make sure every bit of the CPU surface is covered evenly, because obviously when you put it in the middle, you're going to have more in the middle. And then there's people that talk about scratching CPUs and things like that. But again, the thermal compound, the whole point of it is if you were to look at the surface of this heat shield that I'm covering right now with this thermal compound, you'd see little microscopic nooks and crannies. And this just fills that in. That's really all it's doing. and it's helping more efficiently transfer the heat away from the CPU and onto the bottom of our heatsink fan. See, that's really pretty. I like that. I didn't get my fingers too dirty. I can just take this and throw this into the trash. And clearly, as you can see, I have barely used any of this thermal compound. There's at least 5 more applications in here. So save this and put it away, because you could use it on other heat sinks. It doesn't have to just be used with this specific Cooler Master. You can use it on any heat sink. So if you have an older system, if it's more than 4 or 5 years old and you've never replaced the thermal material on it, you could certainly use this. And like I said, you only apply it to one or the other. Either apply it to the CPU or apply it to the heatsink. The problem with applying it to the heatsink is, how do you know where to apply it? How do you know where to cover the CPU? So that's why you cover the CPU, because that's the thing you're trying to keep cool, not your heatsink. So now we can remove this plastic cover. I've seen people install these and they've left this on. And that's bad. You're going to have a terrible smell, and your system's going to run hot, or hotter anyway. And we're going to turn this in the direction we know we want to install it in. So we know we want this fan blowing the air towards the back of the computer. So this is the direction it's going to be in. I'm going to place this bracket, the little post, into the hole here. It feels like it's good and locked into position. And then we're just going to lower this on, just like so. And I can see I'm already going to have a problem. This fan is going to block our ability to tighten the screws. So I'm going to just grab the plastic here on the side. And if we just loosen it up here, there we go. And this fan will just come right off. It'll also help you see a lot better of what I'm doing. Just set that there for now. And all we want to do is just line up these screws with the standoffs below. Now, do not over tighten these. You just want them to be to the point where you just can't turn them anymore. And be careful with the screwdriver. As I said, you don't want that to slip and slam across your motherboard. And you know, by having it here on the floor, working with gravity helps a lot. And that's locked into position. It's not moving. And if you take a close look at the fan, you'll see these are the little brackets that are included. And here are the little foam pads. And what connects the little bracket is the small screws that the pads are actually covering up. So that's why you see the little small screws, the brackets, and that sheet of foam pads that breaks apart into these 4 pieces that are left in our spare parts. This just snaps back on. It's got a plug here onto this white connector that's for the CPU power. So I might as well have the cable come out that side. And what you'll do is just take the little notches and line them into the groove on one side and get the altitude right on where you want it. So here we don't want to run into our RAM, so we can raise this up just a little bit. What I've done is I've got this little tab that's sticking out on the plastic on the fan into the side groove on both of the ones that are closest to me. Then I'm simply going to slide the fan forward and it should lock into position. Not quite there. Almost. Yep, we're there now. And then, again, a very difficult shot to give you, but right down here, if you can see my finger down here, I'm not sure if you can or not. Maybe I can tilt this up a little bit for you. Right down there is the white connector for our CPU fan plug to plug into. You can only go in one direction, and it does help to have small hands to get in there. And in some ways, you know, if you do have large hands, it may be easier for you to install this before you mount the motherboard into the case. But if you do that, it does make installing the motherboard a bit more difficult. So one way or another, there's going to be a little bit of a struggle. It's unique to these large style air coolers. A liquid cooler in some ways is a lot easier to install, but I'll never have to worry about this leaking. And this runs oftentimes quieter than a liquid cooler, though that just depends on which liquid cooler you have. With that done, we can start with our wiring. In my opinion, there's too many people that are intimidated by the wiring that's involved in creating your own computer. In fact, so much so that they won't even begin the project. It's my goal in my videos to show you just how easy this stuff is, and there's no reason to be intimidated at all. You just simply take it one cable at a time. Generally speaking, if the cable fits, you have it in the right place. And if you follow along with me, there's nothing to fear. One cable at a time, that's all it takes. So we're going to start by removing all these front port umbilicals from being tied to the case. They use these wire ties from the factory, and these wire ties have metal in them, so you don't want to leave them in the system because over time it'll become brittle and break off, and you'll have a piece of metal floating around inside your case, and if you move or bump the case, that metal could, you guessed it, short something out. And when that happens, it's bad news. So if you want to keep cables tied up, that's fine. Use a nylon zip tie. Don't use the metal wire ties that ship from the factory. So even if it's a cable you're not using, like here we've got our front fan right here, for example, we're not going to use this front fan. There's nothing to cool here. There's no hard drives to cool. There's no CPU. There's no graphics card to cool. So there's no reason to have that fan on, especially here in Arizona, where we have so much dust. All it's going to do is bring more dust in. This rear exhaust fan, as well as the CPU fan, are going to create a natural vacuum that are going to pull air into the system. Some people worry about dust or things like that, but you should be opening the computer once or twice a year and blowing the dust out of it, regardless of how many fans you have or how they're configured. Now, for example, since we're not going to be using this fan, I'm going to remove this wire tie. Whether you untwist it or cut it off, just get rid of it. We don't want it in the system. Oops. And then we'll just grab one of the nylon zip ties that came with the case. We're just going to put that right back on. It's ironic, right? The case manufacturer gave us those nylon zip ties. And then I can just stick that right down in there. And that'll be neat and out of the way. Now, there's no harm in hooking that fan up if you want to. This motherboard certainly has enough fan headers for that, but it's simply not required. And I get a lot of phone calls for repairs that are based on nothing more than noise, which is always caused by a fan. So that's the logic and the reasoning behind that. Then I want to go ahead and remove this other wire tie here that's holding on all of our front port umbilicals. Let's get that out. And we'll pull these through. Now, we're not going to hook all these up yet, and again, don't be intimidated by these. They're actually quite simple. And I just want to take the moment now to untangle them. It'll be a lot easier to do that now than after we've got them hooked up. So the first cable we're going to hook up is the motherboard power cable, because regardless, once again, if it's Intel or AMD, they all use the same power cables. So in the bag that came with our power supply, we have a bunch of cables. We are not going to use all of these. Most of you will not use all of these, and you're not supposed to. You're supposed to have extras for when you want to add things to your system later. Unless you're somebody who just ordered everything and you want to fill everything up, every blank hole, then you might need all of these. In fact, you might need even more. So what I want is the very large connector, the biggest one. That's our motherboard connector. You'll see one end of it is split, and that split side right here on the side says Type 4. Where it says Type 4 on these Corsair power supplies, that's the end that plugs into the back of the power supply. So again, we want to remove the wire tie. I liked it better when I was cutting these off. It was a lot faster. Get rid of that wire tie. Throw it away. Never want to see it again. And these other cables, just set those aside for right now. And on the back of the power supply, here's a separate close-up, but we're going to plug in the large connector on the bottom right side of the power supply, and then the smaller one on the split cable goes right beside it. So that's going to go on. If we do the small one first, because that one will be harder to get to once the large one's in place, right? So work on the inside, working your way out. And you should hear them click when they go in. And if you give the cable a light tug and just visually inspect it, make sure it's fully seated. And then we can run it right through this wiring grommet hole right here. right out to the back. If we spin this around, we can bring this up through here. And we want to plug it in here. It's only going to plug on one way. There's a clip here on the outside edge. And we want to align the clip on the plug. And just line it up. And then once you've got it lined up properly, it may require two hands, and you're just going to push that on, and you should hear it click into position. Just like that. And you give it a light tug, that's not going anywhere. Next, we're going to hook up the CPU power connector. That's right up here in this left corner. So looking back at our cables, we're looking for an 8-pin connector. It's not these, because these can be 8 when you add the little spare set, like so. But this is actually for your video card. And the ones for the video card on the side will say PCI-E. So we don't need that at all because we're not even using a GPU in this system, not a discrete graphics card anyway. The GPU is built onto the CPU. Like I mentioned earlier, half of that CPU is nothing more than video card. And this customer is going to be using this for business. They have no desire to play games. They want to make some money. And that's exactly what this system is going to do for them. If, on the other hand, something's changed and they want to play games later on, they can easily add a discrete graphics card. And that's why we're always going to hold on to the cables we're not using. And that's an example of that. Just like this Molex connector to 4-pin, it's an old floppy drive adapter. Some USB hubs, I think, will take these little adapters, little specialty hardware devices. But for the most part, most people are never going to use this. But you never know, so put it away. So back to getting that 8-pin power connector. That's what I've got right here. And you know, this is one of those cables that you look at it and you go, well, both ends look the same to me. Does it really matter? Well, there is a reason why one end says CPU on the side and one end says Type 4 on the side. So it's my advice that you follow the manufacturer's advice and plug the end that says Type 4 into the back of your power supply. On the back of this power supply, it's actually going to go into this part right here that says 6+2 PCI-E and 4+4 CPU. This is a 4+4 CPU connector. So there's a total of 8 of them if you count them. That's 4+4. It's rocket science, I know. So I'm just going to plug that. It'll actually go into either of the two, but I'm going to plug it into the one closest to the edge. And once again, you will hear it click when it goes in properly. Just got to get it lined up. There we go. Then we're going to feed this one out through the back, take up all that slack. We're going to come around here and right up in this top corner, it's a little bit tight. We got to get this right up in here. There's a hole right up at the top. And this can be a little bit tricky. We'll get it there. You know, the more expensive the case, generally the easier this is. And some of the cheaper cases don't even have a place in the back to run this cable. So the cheaper cases generally look awful on the inside because they don't really allow for any cable management at all. And you know, it's interesting that this is a Corsair case and a Corsair power supply, and you think the two would just fit perfectly. But you can see it's a very tight fit. And I'll tell you something else. You saw my thumb just slipped and it went up into this groove. No harm done. On cheaper cases, I'd be grabbing a Band-Aid right now. So another reason why you really don't want to cheap out on the case. And of course, it doesn't mean you have to spend $200 or more on a case either. But generally speaking, $60 or more will get you a good case. Anything under that is, in my opinion, junk. In this industry, you really do get what you pay for. There we go. I don't know what I did differently, but just stick with it, be patient, don't get frustrated. If you find you are getting frustrated, you need to walk away, go watch a little TV, get your mind off of it. This should be an enjoyable process. Don't be in a hurry to get it done, because I promise you, as soon as you get it done and it fires up and you're all excited and you're happy, you're gonna want to build another one. All right, so with that through, same thing, we've got a clip on one side, and the ridge that clip's going to click on is again facing the outside edge of the motherboard. And line it up, push it straight on. And then we can pull the slack back into or back out to the outside of the case here and get it away from this heat sink. There we go. That way our cabling looks nice and clean. So there we've already applied power to the motherboard. Now I need to apply power to this optical drive. So looking back through our cables, this is actually the last power cable we're going to need. All the rest of these are, well, and that one, are all spare. So we don't need that one, don't need that one, and these two are identical. So it doesn't matter which of these two we're going to use. We're looking for the one that has the SATA power connectors on it. It doesn't matter which of those 3 SATA power connectors you want to plug into the back of the optical drive or any hard drive. It's all about kind of measuring out what's the best way it's going to look. So for me, well, again, I'm going to start by plugging into the back of this power supply. There are 3 places that this can plug into. And just to keep the cabling as neat as possible, I'm going to keep it along the bottom, just to keep all the cables close. Plug that straight on. I'm going to run it through the back. And then all the way up here, we'll bring it back in. And then finally, right here onto the back of our optical drive. Next, in the motherboard box, you're going to find and pull out your SATA data cables. Now, some motherboards will come with 2, some motherboards come with more, but there should at least be 2 that were included with your motherboard. With this ASUS board, one of the pair that were included has a right angle to it, or a 90-degree bend. We're going to take that end of it, and we're going to plug that right here onto the back of our optical drive. Now I'm going to take the other end of this cable and run it right out through the wiring grommet, right out here, and then right back down. Doesn't do much, but it does help a little bit to hide the cabling. And the SATA ports, we've got 4 here and 2 here. And you'll have to refer to your motherboard manual on your board to determine which ports are which. On this board, they're numbered 1, 2, 3, 4, and then 5 and 6. Now, technically, you can plug this into any of those 6 and it's going to work just fine. I like to plug in the first drive into port 1, the second drive into port 2, etc. So since this is the first drive that's SATA-based, not M.2, obviously, it goes into port number 1, which is just right here. Spinning the computer around, now it's time to start hooking up our front port umbilicals. And again, nothing to be intimidated about. We have one very easy wire to connect here. This is our HD audio cable. If you look very closely, it says HD audio. And it's got a pin that's missing on one side of it. And what we're going to do is bring that in as far back to this corner as we can. So I'm thinking if we bring it in right around here. And on most motherboards, the front port audio connector, which is your headphone jack and your microphone jack, that connector is usually somewhere in the left bottom quadrant of the motherboard. And here on this motherboard, I can see already it's right here. It's the very last connector just above the power supply. And you just have to make sure you orient this with the blocked pin lining up with where the missing pin is, which is on the top in our case. And then we just plug that straight on. The next cable we're going to hook up is also very easy. This cable right here hooks up our 2 front port USB 3.0s. It's a pretty unique looking cable. It does have a little notch on one side, so it only goes in one way. And if we look at the motherboard and see where our connector is, it looks like we've got 2 of them. We've got one we can use down here, or we can use this one right up at the top. So I'm going to use this top one. So I'm going to bring the cable in, I guess right under here I think will be a good place. So we'll just grab it, run it behind these other cables, and put it right in there like so. Then we turn this around, and this, like I said, has a little notch in it, and there's a little cut out in the socket that it's going to plug into. And when you push it on, you should hear it click right into position. Now finally, we have all of the scary cables. These are your power switch, reset switch, hard drive LED, and power LED. And they're all labeled accordingly. So it's really quite simple, as I mentioned, when you just handle it one cable at a time. So I'm just untangling these right now while I can. And these are all going to go, on most motherboards, on the bottom right quadrant. So I'm just going to bring them down through this wiring grommet here, pull them through. And this area here is where we're going to plug them in. Now, ASUS gives us that Q connector, and in my previous build video with a fall 2016 build, there's a good close-up of how that Q connector works. And to me, that Q connector is kind of pointless in that the cables keep falling off of it. I like Gigabyte's implementation of what they call their G connector because it actually holds the connectors on. So I hope ASUS reevaluates and re-engineers their connector that secures the cables onto the connector. But now I'm actually going to not use that connector, just plug the cables on individually, as you do with most motherboards anyway. Either way, they all go in the same place. And we start with the hard drive LED. The hard drive LED typically has some indication on it of what side is positive and what side is negative. And on these Corsair cases, you know, I really wish that they would change their cabling a little bit. Usually red and white or red and black. Red usually indicates positive and black indicates negative. So what do you do when your cable's entirely black? Well, if you look closely, one of the black cables has a white stripe on it. That indicates your positive side. Also, here on the end of the connector, very, very small is an arrow, and that indicates the positive side of the cable. Basically, what all this amounts to is the writing that says HDD LED should face down. We're going to install it on the first 2 pins on this connector in the lower left and just push it straight on. We want that positive cable towards the outside edge. Next, we have our power LED, and that's going to go on the same way, just above the hard drive LED. The positive cable is going to go above the positive cable, and the negative cable above the negative cable of the hard drive LED on the 2 pins directly above. Then, what do we have here? This is our reset switch. And the reset switch goes on the next 2 pins beside the hard drive LED. There is no positive or negative, even though it may say positive or negative on the cable or even on the motherboard connector. It's a switch. There's no such thing as a switch that has a positive and a negative. And then that just leaves us with our power switch. And the power switch, much like the power LED, goes directly above the connector below it. Now there's just one last cable we have to plug in. Can you believe that? We're almost done. And that's just the rear exhaust fan. And so I'm going to remove the wire tie from the back of this that's holding this cable on. This should be the last wire tie in the system. If you're using a different case or whatever computer you're using, be sure and just double check that you've found, located, and removed all of these metal wire ties. Now, there's a number of different places that we can plug this rear exhaust fan into. I want to choose the closest connector. That's going to make our cabling look as clean as possible. Now, right now, our cabling doesn't look all that great, especially not from this side. But you always save your cable management for last. We want to make sure everything's going to work before we spend all the time and effort in making it look pretty. So getting back to plugging in our fan, we've got a fan header that is right here. It's kind of dark in there. Try and give you a close-up shot of that. This is a 3-pin fan going onto a 4-pin fan header. That's fine. There's nothing wrong with that. There's little grooves on the connector that are going to line up with the tab that's sticking out on the header, and it just slides right on. Okay, this is where it gets exciting. We're going to see if we built everything correctly. If we did, we should get a screen, some sort of text or BIOS on the screen. And if that passes, then we can go ahead and install Windows and get the system configured and clean up all the cabling because there's simply no other parts left to install. So to do this, the first thing I want to do is plug in my wireless keyboard and mouse, which I have the little wireless dongle here. And I'm just going to plug that here in the back using one of the USB ports up towards the top of the case. And then I'm going to grab the DVI cable here. Now this motherboard has DVI and HDMI out. You can use them both at the same time for dual monitors. I'm going to just go ahead and plug the DVI cable in. And then the last thing we're going to plug in is the power connector. Make sure that the switch on the back of the power supply is in the off position. And we'll just go ahead and plug that in and then flip the switch to the on position. Now, because this is a test, we don't want to plug anything we don't absolutely have to have. So no internet, no flash drives, no printers, just the bare minimum. Let me step around, hit the power button. Let's see what happens. Okay, here we go. Power lights come on. CPU fan is spinning, rear exhaust fan is spinning. I heard the optical drive just initialize. That's all good. Now your very first power on, you want to give it up to a minute while it registers what CPU you have installed, and here we go, it's already started. And it even recognizes, it says new CPU installed, please enter setup to configure your system. Press F1 to run setup. It verifies right up here at the top the ASUS TUF Z270 Mark II with the Intel Core i7 7700K CPU at 4.2 gigahertz, speed 4200 megahertz, total memory 32 gigs right there, and that measures the speed. All of that's correct. It finds our keyboard and our mouse and our optical drive. Perfect. So what we can do at this point is we can hit F1, go into the BIOS, and configure that. I don't show the BIOS configurations because every BIOS from every motherboard is different. Even the same manufacturer, ASUS, across their line of motherboards, the BIOSes vary depending on the features of the motherboard. And so it doesn't make a whole lot of sense for me to show it because it's very specific to each individual board. But in here you can set your date and time, and you can even have the easy tuning wizard for overclocking and adjusting the fans and such with the ASUS brand boards, which is really great. In fact, I think Gigabyte and MSI and ASRock all do it all too, but I think ASUS is the one that they're all copying on that. But be that as it may, this is a successful power on self-test. So what I'm going to do is, I was just looking to see if I can see what version of BIOS I have, because if there's a new version of the BIOS, which I doubt, this motherboard just came out 2 weeks ago, as did the CPU. But if there is a new version of the BIOS, I'll put it on now. Then I'm going to go ahead and install Windows. Now, I have previous videos for how to flash a BIOS. I have previous videos on how to install Windows, both Windows 7 and Windows 8. I have not done an installation for Windows 10, but it's basically the same as installing Windows 8. You just put the disk in or put your USB flash drive in and follow the prompts on the screen. It really isn't more complicated than that. So off camera, I'm going to go ahead and get Windows 10 installed. I'm going to get all the drivers installed. I'm going to get all the Windows 10 updates installed. I'm going to get Windows 10 activated. And I'm going to clean up the cabling. And when I come back, the final thing we'll have to do then is put the panels back on and show you what it looks like with the cables all cleaned up on the inside. Okay, now here we are with the cable management all completed. You can see how nice and clean that looks there on the inside and on the back side. I do wish Corsair made this Corsair 200R case just a little bit deeper, because it can be a little difficult when you have all the cables here to get that back panel on. But before we do that, let's boot it up real quick and see how fast it boots. So I'm going to hit this and then this. It's always exciting to see a brand new computer boot. You'll see that the logo's changed since I've updated the BIOS. If you recall on the test boot, we're already up, I think it said 14 seconds on that. And you can see even though the icons down on the corner have already loaded. Now that we know everything works correctly, now we can put the side panels back on. I always start with the side panel on the wiring side, on the back side here. And you'll see I got a big lump of cables right here. And it's going to make that back panel fit pretty tight. It's similar to trying to close an overstuffed suitcase. Now, this back cover is going to go on tight, but I'm going to show you how I do it. Let's see what's going to give you the best angle here. You'll see I've had to take it off the Lazy Susan to do this because I don't want it moving around while I'm trying to secure the panel and make a tough job even tougher. So we're going to start by grabbing the side panel that does not have any holes or windows. That's this side. And what I do, especially when I'm worried that the cables may be too thick here, is I just set the cover on, and you can see it will not sit flush because those tall cables are keeping it from sitting flush. But I can push down on it. So what I'll do is I use both hands and my elbows, and I push down with my elbows, and I'll grab the edge of the case and kind of use my chest and just push it straight on. And then I feel the edges to make sure there's no bowing. It'll bow if you fail to get one of the notches into the slot. And if you're like, well, I'll work on it later, that'll stay that way. If you leave it there too long in that position, it'll actually change the shape of the metal. And unless you're really good with metal work, you probably will never even get it to straighten out. Even if you put it back a couple days later with the tab in the slot, it'll always have that warp. You'll always see it. So you can see you can push down on the cables and kind of squish them down to a certain extent. So if you're really struggling with it, simply redo your cable management. Now we can go ahead and secure that panel into position. And for that, I'm going to grab those thumb screws, which I have right here, and my screwdriver. Of course, you don't have to use a screwdriver to tighten these down, but using it will make this video go a bit faster so you don't have to sit there and watch me spin 4 screws with my fingers. And remember, this screwdriver has a torque setting which shuts off when it hits the torque that I've set, which in this case is torque level 3. And I pretty much use that on the entire computer build, a torque level of 3. And then finally, our last side panel. And of course, that's the one we've got here, the one remaining, and it has the holes in it. That's for additional fans if we want to add them. Some case panels have windows on them. You don't have to worry about mixing them up. It's just a matter of saving time, because if you grab the wrong panel, you might mess around with it before you figure out it's not going to go on. So the right side can only go on the right side, the left side can only go on the left side. There may be some cases out there where that's different, but that's the overall rule in general. And final 2 screws, here we go. You'll see I have to push the case in just a little bit, but make sure that it's flush. Sometimes when you have to push that case in, it's because the tab is not in the slot. In this case, the tabs are in all the slots. I can feel that it's flush, but it still has that little bit of wiggle room there. That's it. That's our build. And now, this is ready to deliver to a very happy customer. I'd be happy if I had this, I'll tell you that. And I just need the extra cables for the power supply and our extra parts that I put in the motherboard box. And this customer's local, so I'm just going to put it in the car and take it over there. I hope you enjoyed this build featuring the latest Intel processors, the Kaby Lake processors, and the Z270 chipset. And I look forward to seeing you very, very soon. Until then, bye for now.